Hello, I'm Chris Hart with ARI Flow Control. In this video, we'll see how a backflow preventer works from the inside. Understanding how a backflow operates becomes much easier when you can visually see the water running through the backflow assembly. With a series of animated videos, we can illustrate the mechanical movements of the components during a back pressure and back siphonage condition. The first video will illustrate a normal flowing backflow. When pressure on the inlet side exceeds 2 psi, water flows through the sensing line in the upper chamber of the diaphragm, depressing the spring, closing the release valve. When pressure exceeds 5 psi, the first check valve opens and the zone fills. After the zone is filled, the second check opens. The gauges show the differences in pressure. When we close the inlet shutoff valve, the first check valve closes, second check valve closes, no backflow gets through. The relief valve opens. We've looked at a normal operating backflow and a shutdown process. Let's turn our attention towards foul checks under both the back pressure and back siphonage conditions. The first failure is the debris in the first check. When there's debris in the first check, pressure between the relief valve chamber and the zone equalize, and the relief valve opens. A leak from the relief valve will alarm of the problem. Second failure is back pressure in the downstream. When the pressure in the downstream is higher than the pressure upstream, second check closes, then the first check closes. In the third failure, we'll see back pressure with debris in the second check. The pressure in the downstream is higher than the pressure upstream, and there's debris in the second check. Second check closes, then the first check closes. No contamination can get through the first check. When pressure goes up in the zone, the relief valve opens and the water drains out. The next failure occurs when there's leaks in both checks. The change in zone pressure will cause the relief valve to open. The leak will warn about the problem. So after we've seen failures in a back pressure condition, now let's look at failures in a back siphonage condition. The fifth failure is back siphonage in the upstream. In this situation, the second check valve will close and leave the downstream line full. The first check valve will close and no backflow will get through. The sixth failure is showing back siphonage upstream with debris in the first check. Now the second check valve will close and leave the downstream line full. Air will get through the first check valve, back into the service line with no backflow. The last failure is back siphonage in the upstream with both check valves leaking. During this phenomenon, the pressure loss will open the relief valve and the leak will drain through. After watching the animated videos, we hope you have a better understanding of how a backflow preventer works. And from all of us at ARI, thank you so much for watching.